how to use reference angles to evaluate trigonometric functions. If you remember, we said that sine theta is equal to plus or minus sine theta prime. Cosine theta is equal to plus or minus cosine theta prime. Tan theta is equal to plus or minus tan theta prime, where theta prime is the reference angle of theta. And plus or minus, you choose it according to the quadrant in which theta lies. If theta lies in the second quadrant, for example, then sine should be positive and cosine is negative and tan is negative and so on. Let us solve some exercises from the book. In exercises 61 to 86, use reference angles to find the exact value of each expression. Do not use a calculator. So you have to show him your steps. The first thing to do is to graph the angle in standard position. This is in degrees. So I know that here 180 and here 270 if you go in the positive direction. So 225 is greater than 180. So it would be somewhere here in the third quadrant. So this is the angle 220 degrees. Good. So now what is the reference angle of this angle? This is the reference angle, the angle between the terminal side and the x-axis. This is the reference angle. To find the reference angle, I subtract 225 minus 180, and the answer would be 45 degrees. So the reference angle of 225 degrees is 45 degrees. So now also the angle 225 lies in the third quadrant. In the third quadrant, cosine is negative. So cosine 225 would be equal to negative cosine 45, because 45 is the reference angle of 225. And you can find cosine 45 by calculator. It is 1 over square root of 2, or if you rationalize the denominator, square root of 2 over 2. Or you can use the triangle. We know that there is a triangle for 45 degrees. Okay, if this is 45, this is the right triangle, then we have these numbers, 1 square root of 2. You can use this triangle without a calculator to find cosine 45. Please do the same to find sine 2 pi over 3. This is an exercise for you. Okay. Now use reference angles, same question, to find the exact value of each of the following trigonometric functions. Do not use the calculator. But maybe this angle now is greater than 2 pi. So when the angle is greater than 2 pi, you find a coterminal angle to this angle. And to find the coterminal angle, you add or subtract a multiple number of 2 pi. 2 pi in this case is 6 pi over 3. We have the denominator 3. So I start by 14 pi over 3 and subtract 6 pi over 3. If you subtract 6 pi over 3, you will have 8 pi over 3, and this is still greater than 2 pi. So I need to subtract another 2 pi, which is 6 pi over 3. So I have 2 pi over 3. So 2 pi over 3 is coterminal to the angle 14 pi over 3. So tan 14 pi over 3 is equal to tan 2 pi over 3. If the angles are coterminal, then their trigonometric functions are the same without plus or minus here. All right. Now I need to sketch the graph of the angle 2 pi over 3. The graph of 2 pi over 3 would be The same graph as 14 pi over 3, but with different rotations. They will have the same terminal side. That's why they are coterminal. 2 pi over 3 is easy to graph because this is 3 pi over 3, and 2 pi over 3 is less than 3 pi over 3. So this is the angle 2 pi over 3. Good. If you add 4 pi, you will reach the same angle, 14 pi over 3. Good. Now we need to find the reference angle. Where is the reference angle? This is the reference angle in the positive direction. So it is theta prime. So what is theta prime in this case? Theta prime is 3 pi over 3 minus 2 pi over 3. So it is pi over 3. Okay. And 2 pi over 3 lies in quadrant 2. This means that tan 2 pi over 3 is negative because in the second quadrant, tan is negative. So I can say at the end that tan 14 pi over 3 is equal to tan 2 pi over 3 because they are coterminal is equal to negative tan pi over 3, which is the reference angle. And tan pi over 3 I can find from the rectangle, the right rectangle. This is pi over 3. This is 1 and this is square root of 3. And this is 2. So tan pi over 3 is opposite over adjacent. So the answer is negative square root of 3. And you can check this answer by calculator. If you write this line, this means that you understand the difference between coterminal angles and reference angles, and you really understand the subject. Okay, let us find also secant negative 17 pi over 4. Okay, 17 pi over 4 is greater than 2 pi. 2 pi here, because the denominator is 4, the numerator should be 8 pi. 8 over 4 will give you 2. Okay, so I need, this is a negative angle. Negative 17 pi over 4 is a negative angle. So I will add 2 pi to make it, to come to a positive coterminal angle to this angle. Okay, negative 17 plus 8 is negative 9. Negative 17 plus 8, of course, negative 9. Okay, negative 9 pi over 4. Now, still 9 over 4 is greater than 8 pi over 4. So I will add another 2 pi, another 8 pi over 4. So the answer is negative pi over 4. Now, negative pi over 4 is okay with me. It's a negative angle, but it's okay. So we can say that secant negative 17 pi over 4 is equal exactly to secant negative pi over 4. Why? Because negative pi over 4 and negative 17 pi over 4 are coterminal angles. So to find secant negative pi over 4 now, I need to graph this angle in a standard position. This is a negative angle, so I will go in this direction, and immediately I will reach negative pi over 4 because this is negative pi over 2 if you go in negative direction. Now, where is the reference angle? It is this angle in positive direction. So theta prime is pi over 4. Well, we are in the fourth quadrant, so secant negative pi over 4 in the fourth quadrant would be positive because secant is the reciprocal of cosine, and cosine in the fourth quadrant is positive. So secant negative pi over 4 is positive. So now I can say that secant negative 17 pi over 4 is actually equal to secant negative pi over 4. is actually equal to secant pi over 4, which is the reference angle, is equal to, and if you use the triangle of pi over 4, which is this triangle, secant is 1 over cosine, so it would be square root of 2 over 1. So this is the answer. More exercises. Please try these by yourself. Okay, these are similar to the previous ones. Over 3, I solved 1 over 3. Let me solve over 6 for you. Okay, so let me solve a cosine 17 pi over 6. Now we need to find cosine 17 pi over 6 without using a calculator, using reference angles. First, this angle is greater than 2 pi. 2 pi, because the denominator is 6, is 12 pi over 6. This is 17 greater than 12. So I will start by subtracting 2 pi from 17 pi over 6. I reach 5 pi over 6. Good. Now 5 pi over 6 is less than 12 pi over 6. So 5 pi over 6 and 17 pi over 6 are coterminal angles. Coterminal angles. Good. Now to find cosine 17 pi over 6 or 5 pi over 6, I need to sketch the graph of 5 pi over 6. It's a positive angle. I'll go in the positive direction. The denominator is 6, so this is 6 pi over 6. 5 pi over 6 would be before 6 pi over 6. So this is the angle 5 pi over 6. Now, what about the reference angle? The reference angle is in the positive direction. This is theta prime. How to find theta prime when you are in the second quadrant? You subtract 6 pi over 6 minus 5 pi over 6. So it would be pi over 6. Good. So now I can say, before that, let me check in the second quadrant what happens to cosine. Okay. Cosine 17 pi over 6 or 5 pi over 6, the same, is less than 0 because cosine in the second quadrant is negative, since 17 pi over 6 lies in quadrant 2, which 5 pi over 6 also lies in quadrant 2. So I can say now that cosine 17 pi over 6 is equal to cosine 5 pi over 6, the coterminal angle. Now we go to the reference angle. The reference angle is pi over 6, but cosine should be negative. So I put a negative sign. So the answer is negative, and pi over 6 is the angle here. This is pi over 3, and this is pi over 6. So cosine pi over 6 adjacent over hypotenuse. So it is negative square root of 3 over 2. And finally, you can check your answer by calculator. More questions about the same point. Please do tan 9 pi over 4, and tan negative pi over 4 is also similar. We did something like it. Let us do secant 495. It's clear that this angle is greater than 360. So I start by subtracting 360 from 495. The answer is 135. So secant, so I have 135. Now 135 is less than 360, so that's good. And I start now by graphing 135. This is 180, so 135 would be somewhere here. This is 135. This is the angle 135. And now secant 495 would be less than 0 because 495 lies in the second quadrant. lies in the second quadrant, and secant in the second quadrant is negative. So I can say that secant 495 is equal to secant 135, which the coterminal angle equals. Now secant is negative, so it should be negative. Secant of the reference angle, which is the reference angle, of course, here. What is the reference angle? Theta prime is 180 minus 135. So the reference angle is 45. So secant 45. And 45 again from the triangle. Cosine, it is negative square root of 2. That's the answer. And you can check your answer by calculator. Uh, Let me do the last one, 85, and I leave 83 and 81 for you. Please, the same method, just practice at home. By practicing, you master the subject. So this is the last example. Now, negative 17 pi over 3 is greater than 2 pi because 2 pi is 6 pi over 3. You can, by the way, you don't have to add 6 pi over 3 and 6 pi over 3 and 6 pi over 3 again. I can add immediately, for example, 18 pi over 3. And why 18 pi over 3? Because 6 times 2, 12, times 6 times 3, 18. So by adding 18 pi over 3, this is in fact 6 pi. If I can add 6 pi, 2 pi, 4 pi, 6 pi, 8 pi, I will get pi over 3. And this is an angle in the first quadrant, coterminal to negative 17 pi over 3. And this is the graph of this angle. And actually, the reference angle of any angle in the first quadrant is the same angle. So theta prime is pi over 3. So in fact here now sine negative 17 pi over 3 is equal to sine pi over 3 because pi over 3 is coterminal to negative 7 pi over 3 and at the same time it is the reference angle. Okay, فsine pi over 3 again by the table, by the triangle, it is opposite over hypotenuse, so it's square root of 3 over 2. This was the last example. I stop here and I open the floor for questions.